Class. Sorry I couldn't be in class with you today, but I thought by doing this through video, I'm still there in class and you still get the lecture. You should have a piece of paper for you for your notes. This time we're going to still relook, as this whole week we've been practicing in the first fundamental theorem of calculus. So first fundamental theorem of calculus. If you forgot what it is, again, it is, what the first fundamental theorem of calculus means is that if you take the antiderivative of the derivative, you get the same thing as the antiderivative of the upper bound minus that of the lower bound. So that's all we've been practicing all week. Whether it's without u substitution, with u substitution, we've been practicing over and over again, taking the antiderivative. And by doing so, the antiderivative of a derivative, we, long story short, again, plug in the upper bound and subtract the lower bound. So there's a lot more to this theorem. It sounds very simple, but there's a lot of depth to it, and that's what we're going to practice today. So 3 different applications that you're going to learn today. The first application is this, and all of these are straight from the AP or example AP questions that you will definitely see on the test. So for this example, it says, if f prime is f of x minus 3 and f of 2 is 7, then what is f of 5? And you're probably like, I have no idea what to do or what it means. First thing you do every time you see a problem like this, you see you have a derivative problem. You see they give you an antiderivative of two different values. So what I'm going to do is I'm going to start with the formula for the first fundamental theorem of calculus, which is antiderivative of a of b of f prime x dx is equal to the antiderivative of b minus the antiderivative of a. Now, just like most of the stuff that we do in math, we're going to plug in the stuff that they gave us. Okay, a to b. You may not know, like, what the heck is a and what the heck is b. A and b are always going to be the numbers that they give you, the x values that they give you. In this case, it's 2 and 5. So I'm going to put 2 to 5. F prime they gave us, which is 4x to the third minus 3 dx. F of b is going to be f of 5, and that's what we're looking for. We don't know what that is. And then they gave us f of 2, which is f of a. So I'm just going to put in 7. Okay. Now I'm just going to solve this and solve for f of 5. And to make it easier for you, instead of saying f of 5 and having to rewrite that, I'm just going to call it x. I'm just going to solve for x. All right, the left part you should be very familiar with, the antiderivative. Antiderivative 4x to the third is x to the fourth. Antiderivative of minus 3 is minus 3x. And again, my notation, I'm put this in brackets from 2 to 5. Then I plug in 5, I plug in 2, and get an answer. If I plug in 5, again, since I've done this already, if I plug in 5, I get 625 minus 15. So if I plug in 5, I'm going to get 610. If I plug in 2, I'm going to get 16 minus 6. I'm going to get 10. Okay. So if I plug in 5, I get 610. I plug in 2, I get 10. And then I still have x minus 7. Then from here, it's just algebra. 610 minus 10 is 600. If I just move over, equals x minus 7. Then I add 7 to both sides. 607 equals x. Again, the question didn't ask for x. If I go back to the problem asked for f of 5. Remember, I'm looking for f of 5. So I'm going to say f of 5 is 607. So application number 1, if I give you a derivative and I'm looking for an original value, I can use the first fundamental theorem of calculus. Application number 2, what if you were given a graph? Okay, so it's still the same thing. Check this out. They gave me the derivative. Okay, you see it says f of prime, and they give me an original value, and I'm looking for another original value. Okay, so again, I'm going to start off with the formula. The formula is a to b of f prime of x dx is equal to the antiderivative of b minus the antiderivative of a. Okay, so it should be ingrained in your head how to do this. Okay, a to b, as you see in this first problem, I have an f of 1. Let me highlight in a different color. I have f of 1, and I'm looking for f of 5, so I know 1 and 5 are going to be a and b. F prime of x, they didn't give me a function, so I'm just going to leave this as f prime of x. They gave me a graph instead. F of b, in this case, remember, is f of 5. That's what we're looking for. And f of 1, which they gave us in the original problem, is 5. So same like the last time, I need to solve this. Now, in the last problem, what we did is we looked at this f prime of x dx, and I said, hey, let me take the antiderivative of it. That's pretty simple. But again, there's no function. Instead, they give me a graph. Now, you should know how to find the antiderivative of a graph. If you remember, the antiderivative of a graph means the area. This one says 1 to 5. So if I zoom in to 1 to 5, I need to find, let me use my highlighter, I need to find this area right there. Okay? And some of you are saying like, oh, that's not a real shape. How am I supposed to find the area of that? Last time we did triangles, we did circles, we did trapezoids, whatever, rectangles. How do we find the area of this? Well, if you look at this very carefully, you can see that this area is really just a rectangle minus this circle. So if I find the area of that rectangle and subtract the area of the circle, I will find the area under the curve. This rectangle, you may notice, has a length of 4 and a width of 3. So the area of the rectangle is, I'll put a big 12. Okay? And then I'll erase this 12. So the area of the triangle is 12. The area of the circle, you know that's a half circle. Remember, the area of a circle is pi r squared, but I want half of a circle. This particular circle has a radius of 2. So half pi of 2 squared, which is 4. And then half of 4 is 2. So the area of this circle is 2 pi. So the circle is 2 pi. The whole rectangle is 12. So the area under the curve is going to be 12 minus 2 pi. So hopefully you guys understand that. So this right here becomes 12 minus 2 pi. This is what we're looking for. This is x minus 5. I add 5 to both sides. Your answer is 17 minus 2 pi. Like so. Okay. And I can go over more of the examples. I think that was a more difficult one, but again, I just want you to see how to do it. Okay, fine. Let me do one more example. Okay, I'll leave the formula up. And again, if I'm going too fast, you can pause it, you can rewind it. This one says f of 0. Okay, I left the formula up so I don't have to rewrite the formula. Okay, and obviously since we're doing the same section, you know we're using the exact same formula. So I'm going to do 0 to 1 f prime of x dx equals f of 1 minus f of 0. Again, f of 1 is given to us, so this is 5. F of b is what I'm looking for. Now, I don't have a function. I can't take the antiderivative of not a function. So when I want 0 to 1 of f prime of x, I got to look at my function and find the area under the curve. If I look back at my problem, sorry, let me erase this. If I look back at my problem, you'll notice that from 0 to 1, it's this right here. You notice that that shape is a triangle. Okay, triangle, half base times height is the formula. I have a base of 1. I have a height of 3, which means this area is 3 over 2. So going back here, this whole thing, the left side of my equation is just 3 over 2. Then I'm going to add x. Well, how about this? I'm going to multiply both sides by 2 so I can get rid of the fraction. Then I'm going to add 2x and subtract 3 to get the positive 2x and to get the 3 on the other side. And then dividing both sides by 2, you get an answer of 7 over 2. So that is application 2. Application 1, we did based on just an equation. Application 2, we did it based on a graph. And here is application number 3 on the back of your notes. This is about velocity, position, and acceleration again. Okay. This particular problem says the particle moves with velocity of this function. The particle has this initial value. What is the particle's position at this time? Okay, so I've highlighted the 3 specific points that we need. The great thing about these specific points is that they are cues to use the first fundamental theorem of calculus. First fundamental theorem of calculus, again, a of b minus, or f prime of x dx equals f of b minus f of a. Let's plug some stuff in. In this particular problem, I have a time of 2 and a time of 4. So this becomes 2 and 4. My derivative in this particular case is the velocity, right? I was given velocity, I'm trying to find position. So f prime is 3t squared plus 8t. F of b, which is f of 4, we don't know. I'm going to call that x. And f of 2, they gave me y equals 5. So that's why this one is 5. Now, let's take the antiderivative and solve for x. Antiderivative of 3t squared is t to the third power. Antiderivative of 8t is 4t squared. This is going from 4 to 2. And then this part you should find very simple. In this particular case, I think I solved it also. Let me see what answer I got. If you're doing this correctly, you're going to get 8 on this side. And then I'm going to add 5 to both sides, so you get f of 4 is 13. So I took a little shortcut. You plug in 4, you plug in 2, you subtract the 2, but I did that. Last one for today. Same thing, an application for position, velocity, acceleration. This time they give me a trig function. I know you guys hate trig functions, but I really don't think it's that bad. They give us acceleration. They want velocity at these particular points, t equals 3, and they give me at t equals 0. So if they give me acceleration, I'm trying to find velocity, you know I'm using antiderivative. So, formula, again, a to b, f of prime x dx equals f of b minus f of a. Let's plug some stuff in. They give me 0 to 3, so I know this is 0 to 3. They give me acceleration, which is the derivative of velocity, so I'll put that function in. And then f of b is f of 3, which I don't know. I'm going to call that x. Sorry, it's an ugly x. And then they gave me f of 0 is 6. Like so. Time to solve. Okay, antiderivative sine pi t over 4. Some of you are saying, I have no idea how to do this. It's okay, we did some practice yesterday. And I can't do this as it is, so I'm going to do a side calculation and do u substitution. U will be the inside of my parentheses, pi over 4t, which means du is pi over 4. Oh, sorry, this should be a t. Pi over 4 dt. And to replace dt and multiply both sides by 4 over pi du equals dt. Now let's do my u substitution. Again, the most common mistake that you'll see is that you have to change the bounds. You have to change the bounds because I have to change all the x's into u's. Answer, I think it was Amy's question yesterday. Where do we plug this in? I'm going to take these numbers and plug them into here. If I plug in 0, I'm still going to get 0. If I plug in 3, I get 3 pi over 4. Now, this now becomes sine u, and I had a 4 over pi du. And this still equals x minus 6. Okay. All right, now let's do the antiderivative part. Should be the easier part of this problem, because you've already done this before. I'm going to factor out the 4 over pi. I'm going to put brackets and take the antiderivative sine. Antiderivative sine is negative cosine. And then my bounds are 0 to 3 pi over 4. Okay. Again, this equals x minus 6. Oops. All right. Now, if I plug in, what I'm going to do is I'm going to take out that negative. See how it's negative cosine? I'm going to take out that negative because I don't like the negatives. It makes it messy. So I'm going to erase that negative and put it and factor it on the outside. Okay. If I put cosine 3 pi over 4, again, you need to know your unit circle. Cosine 3 pi over 4, it's on the second quadrant, and everything pi over 4 is radical 2 over 2. So negative radical 2 over 2. Minus, if I plug in 0, cosine of 0 is 1. Remember, think of your unit circle. Equals x minus 6. Okay, this is kind of an uglier problem, like it doesn't have a clean answer. So then all I'm going to do is plug in the 4, or I'm going to distribute this minus 4 over pi to both of them. So now I get 4 radical 2 over pi plus 4 over pi equals x minus 6. I know I'm running out of space, so here, let me zoom in for y'all. So all I did was distribute, and then I'm going to add 6 to both sides. So the answer is 6. Here, I'll put it in a different color so you don't get confused. Let's use green. 6 plus 4 radical 2 over pi plus 4 over pi equals, again, the problem is asking for f of 3. So you give me the acceleration, I'll tell you what its velocity is at 3 seconds. So hopefully you all understand this even though I'm not there. I'm going to have you do a little practice set so that you understand what to do. And then when I see you next, we don't have class tomorrow, but when we have class on Friday, you're going to take a quiz on the definite integral plus u substitution. And then this stuff, since I just taught it to you, it'll be kind of like a bonus extra credit. And then if you don't get it, you have another chance to do it without it hurting your grade. So thank you for watching. Hope you enjoyed. And I'll see y'all when I see y'all. Take care.